Hello guys, welcome back to this another video, and in this video we are going to solve the next problem of our ongoing sheet, that is FRAZ DSA sheet, and we're solving dynamic programming level 1 section linear DB. So today we are going to solve next problem, maximum total damage with spell casting. So yeah, so yesterday we have solved delete and earn, and with this we have completed approx 3, 3, 6, 9, 10 videos from this section. So today we are going to solve the 11th video. So that is maximum damage. Let me open it. So, okay. So the problem is a magician has various spells. You are given an array power where each element represents the damage of a spell. Multiple spells can have the same damage value. It is a known fact that if a magician decides to cast a spell with a damage of power I, they cannot cast any spell with a damage of power I minus 2 and power I minus 1, and also power I plus 1 or power I plus 2. Each spell can be cast only once. Return the maximum possible total damage that a magician can cast. So here, this problem is completely similar to the last one that we solved yesterday. So if you haven't seen that video, so I would suggest you to watch that first. So let me tell you where that
Is arrow.
So
So if
no, this is not that video. So I'm talking about this video. So I will add the description
करोगे
of
अगर
this video in the comment, link of the video in the comment box. So first go to this video and watch and learn. First try to learn that concept, and then come again and watch this video. So basically, in that video, uh, we are picking here. This is just a story that if that magician cast I some the spell with value X, then he cannot cast the spell with the value of X minus 1 and X minus 2. In previous problem, the only difference is there if you pick some X, you cannot pick X minus 1, but here x minus 1 and x plus 1, and here x minus 1 x minus 2 x plus 1 x plus 2 you cannot pick. So you got the problem, and one more thing here is the constraints. So in that video what he did, we tried for all possible values, like we started with the one, and then we continuously move to the all values that are part of the uh, number sequence before uh, the maximum element that is present in this in that array. Let me share my whiteboard, and then let you know guys how to approach this. So first let me talk about the previous problem. So previous problem is delete and earn. There what you can do, you have some number like this. So you have number like this. So there what you can do, if you are picking this 4, so you have to delete all the occurrences of 3 and 5 from the array, and you will get new array like this, and your current answer will be 4. Now you can delete again 4, so your new array will be 1 1 1 2 2 5. Sorry, not 5 here, no 5, no 5 is here. Okay, so your current answer will be 8. So similarly, in that problem you have to try out all possibilities to get the answer. So there one problem we seen that if we are deleting x, so we have to also delete x plus 1 and x plus x minus 1. So here in that problem, uh, if you try brute force approach and trying out each and every possibility, then it will be exponential solution. Okay, so what we did, we solved that problem using dynamic programming, and we just do not care about the futures option. So let me tell you what I mean to say. So first let me erase it. So what I'm saying here is, so in previous problem, when we are solving that, our dp of I, we assume that I is the value that we are picking. Okay, and mm, and the answer will be whatever dpfi stores. We say that this is the maximum answer. Even if you're picking that I, so it stores all the possible answer, or it will store the maximum answer till 0 to that I. Okay, let me explain it in more depth what I mean to say. So let's say here your number is 3 3 1 2 2 3. So I mean, if you pick one, so our in that problem our dp of I is saying that I am picking one. So picking one means dp of one, and it says that we have a subarray. Subarray here means not subarray. It means a partial array. Subarray is not good. Nomen name partial array which stores all elements till one, and maximum cost of maximum profit. Let me use profit word we can get if one is last, means maximum element. So in this way we define our DP. So we, what we did, so DP of 1 we will pick all 3, so DP of 1 will be 3. Now similarly DP of 2, DP of 2 what it means. So we have a subarray, so then subarray partial array, so that partial array will look like this. 3 will be not included. So we have this partial array. So what I'm saying, I am picking 2. If I am picking 2, I cannot pick this one. So my answer will be 4 in this case. Similarly, dp of 3, what means dp of 3? So dp of 3 means we have subarray 1, partial array 1 1 1 2 2 3. Now I'm picking 3. If I'm picking 3, then I cannot pick these 2's, and but I can pick these 3 ones, because I cannot, I have to just not consider the x minus 1 values if our current value is x. So 3 plus dp of 1 will be the answer, right? So let's say dp of 4. So it will be it will be 3 plus dp of 1 6. So maximum value is 6. So this is the brief about the previous problem. So there what we did, similarly we tried till all possible values and we goes till dp of max element. So this is the last problem that we solved yesterday. Now current problem, completely same statement. Okay, what changes? So there x minus 1, and if you're picking x, x minus 1 and x plus 1 will be deleted. Here, if you're picking x, then x minus 1, x minus 2, x plus 1 and x plus 2. So, if we just try to map that problem into this problem, what we will get? We don't need to consider this. We follow the same solution in this problem also. We will only define our DP state as I am picking X and that X is the maximum element till that array element. Okay? So one problem got solved. We use same thing and here. So let's say if you are picking X, so answer contributed by X plus we have to ignore the answer for this value, we have to ignore the answer for this value, and whatever the value, let's say some value is present here, x minus some 3, so we will add the dp of x minus 3. We got the answer. Our question is solved here. But hold on, this is not the complete solution. If you have carefully you had carefully saw the constraints of this problem, then see the constraints of that problem, then what you will realize. So your values in array will be up to 10 to the power 9. So how you can iterate over 10 to the power 9 values, and how we will store all the values? So you have to do something else. You cannot try out all 1, 2, 3, 4, 5, 6, 7, 8 till 10 to the power 9. You cannot loop. Even you cannot store that all values. So in this case, what you can do? So what you can do? You can do one more thing. So there also we computed a lot of unwanted states. Let's say your array elements is like this, 6, 15, 20. It is like this. So there what we did, we computed for DP1, DP2, DP3, and similarly till DP20. Is there any need of doing that these things? No, there is no need, because you can just compute DP1 because you have 1 in your nums. Then you can directly compute DP6, and you somehow try to map the these things using some technique, some logic. We will see how to do that. You can directly compute DP15, DP20. But again, here problem is which DS you will use. So if we want to optimize our space here, so we can directly use map data structure. So we will use map of long and long. So basically we will here store it, it will our DP will be map, DP of directly will store answer. Okay. Now this is one thing. The second thing is when you are computing the next state. So let's say you're computing DP of 6. So your array looks like this: 1, 6, 15, 20. So you computed one DP of 1, map is empty. So there is no any previous state. If there is no any previous state, you can directly uh, you can directly store the answer for that state. That is for 1, let's say it's 1. Now when you went to 6, when you went to 6, like when you go to 6, what you will see? Now you have the contribution for 6. So you added the contribution for 6, but there is restriction that if you're picking 6, you cannot pick 5, you cannot pick 4. So you will just check the previous, which is stored in the DP. So you will, instead of just checking previous, you just try to find out whether 3 is available or not. So let's say you want if it's 6, you cannot take 5, you cannot take 4, but you can take 3. So just try to find the 3, if there is 3 present or not. So if there is no 3, so what you can do? So instead of that, you can do upper bound. Upper bound, what it will give? So upper bound, if you find out the upper bound in map, it will give you. So let's say you are finding this is your map. So it's 1, 2, 3, 4, 5. So here you picked 6. Okay. Now you want to find out 3, whether 3 is there or not. So upper bound will give you the first element which is bigger than 3. So if you try to find out 3, so let's say your map contains 1, 2, 3, 4, and then 6. There is no 6. No, if you find out upper bound of 3 in map, so you will so map will the iterator will point to the uh, uh, element, the first element which is greater than that. So that in this case, this is your map. In this case, it is 4. So it will always give you the first element which is greater than map. Then what you can do, you just go one previous. Why? Because you want 3. So if you want to search 3, so it will, if you there is no way to find out, either you have to iterate over the whole map. But if you want to find out the it quickly, if you do upper bound, it will give the first element which is more than that, and you just uh, find out the previous iterator. So previous will always ensure that that value is less than equal to 4, because 4 you cannot take. So let's say even if it contains only 1 and then 6, it contains only 1 and then 6. Then in that case, what will happen? So it will point to this. It will point to 6. And if it will point to 6, then if you just find out its previous iterator, it always ensure that it will be either 3 or less than equal to 3. That's what we want. Or in DP, we will maintain in this DP, we will maintain the answer sequentially, like the answer that we maintained in the previous video. Please, 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 I will suggest you to watch that video. Otherwise, this video will be little bit difficult to understand. So that's why first understand that and then try to map this problem into that problem. So here we are skipping two things and we are just uh, finding out the other the best answer that are stored in the problem. So there we tried out all possibility for all values. Here we are just trying out for the values that are available in the map and for available that is given in the what I can say, given in the problem, and we are just utilizing that values, and we are storing the answers which are only required for us. So this is here, it is not just medium problem, it is marked as medium, but it is actually a hard problem. And we are only mapping out the answers that are required for computing the other answers. Okay, so let me give you one more example. So if I give you some example, it will be more clear. So let's say we have some numbers like 1, 1, 1, 1, 1, then 4, 4, 4, 4, 3, 5, 5, and 8. So this is number. Now this is our map. This map is DP map. Initially, I will traverse. I will also create one map just for frequency. So for 1, it is 5. For 4, it is 4. For 5, it is 2. For 8, it is 1. So instead of traversing here, because in NumSari we have to traverse for multiple times, so I will store this frequency in map and I will traverse on this map. This is also a map. It's an input map, or you can say frequency map. Now I will iterate. I will go to the first element, 1. DP of 1 is there. No, it is not there. So if there is no DP state, just store the, there is no state in the DP. So it means that is the first step. So what I will do, I will just store 1 for 1. It is answer is 5. Now I will go to next. For 4. For 4, I will try to for 4. I am picking 4. So if I want some, if I want some previous state, so if I am picking 4, I cannot pick 3, I cannot pick 2. But it is possible that there is some other state that is already stored in the map, which whose value is lesser than equal to 2, lesser than 2. So you can see that uh, already one is there. One is sorry. So one is there. So I will first why I'm doing this. So I will first add its answer into the map. So for 4 it will be frequency 4, it will be 16. Now I will update this 4. Why? Because upper bound will be easy for me. Upper bound will be easy for me. So if I will find out upper bound of 4 minus 3, that is 1. Upper bound of 1. So 3, 2 I cannot pick, so that's why I am picking the, this is basically x minus third state. I want to find out the x minus third because x minus 1, x minus 2 I cannot take. So I will pick upper bound of 1. That is, that will all point to the DP of this. So this, it will point to DP of this, but I will just do previous of that that iterator. So previous of iterator will do one back, pointing to one back element, and that will always guarantee that that will always guarantee that key we are picking that we are picking the uh, valid DP state, because that state we can pick. So I can just add the answer for that. So 4 will contain 16 plus 20 21. Similarly, I will go to DP of 5. So I, for 5 I will store first 10. So I know if I pick 5, I can get the value as 10. But one more thing. If, and now again, I will do the same step for 5. I will try to find out whether I can pick some valid state that are computed. So I will find out 5 minus 3. Okay, sorry. Okay. Okay. So I will find out uh, 5, 5 minus 3. So upper bound of 5 minus 3. So it will give 2. So upper bound will point to again 4. So I will do the previous of ITR. It means, so how I hope you guys know how to find upper bound. So it is basically, it is a point iterator, and you have to find out MP DP dot upper bound x minus 3. Okay, this is the upper bound. So this will point to 4, but mm, if we will do previous, it will again pointing to 2, which is guaranteed that this one we can take in our answer. So we will add 10 plus 1, which will be 11. But so we know that this state might be used in definitely by be used for the future computation. So we know that there is some previous state whose value is maximum, and its values not maximum. So as we defined our DP state, that we are computing from the start of the partial array to the current element. So here current element is 5. So whatever the answer is the best, we are storing in the DP of 5. So we know that for 4 it is giving best answer. So instead of 11 we will update this to 21. So similarly, this is the idea how we are computing our answers, because this answer can be useful in computing, let's say some answer for 12, maybe it is used. So that's why if you did not update this value with the maximum, so it will give the incorrect answer, because we know that for this partial subarray that we have constructed, there is some answer which is giving as maximum. So why to do this? Why to do this? There is no way to store 11. Instead of that, we will store maximum element, that will be uh, 21, and it could be used here plus its contribution to give the more profit. So this is the idea behind the problem. So if you try to see the time complexity, so it will be uh, n log n. The reason is we are using map, and we are doing lower bound and upper bound on the map. So for every element we are doing that. So TC will be order of log n into n, and space will be, here we are not using so much space, so only using distinct elements in the array. So we are only using this much space. So this is the overall solution for this problem. So you will get more idea while writing code when I will write code. So let's directly jump into the writing code. So what I have decided that I will create one map of int. So basically I will use some shortcuts. So using ll is just long. So map of ll mp. So mp will store the count of every number. So for auto x in nums, I will do mp of x plus plus, right? Now, so now we did this. So what we will do, we will iterate over for int I equals to 0, I less than. So basically, instead of doing that, I can iterate over map mp. Now I can do, first I can dp of x equals to x into m. So let's say xy, so that it will be easy. So here x will be the key, and y is the value. So I will directly compute x into y, right? Now what I will do, auto itr, I will find dp dot upper bound, and what I will find x minus 3, and I will do previous. Okay, so we got this. Now we will update our dp of x equals to max of dp of x, or previous of itr dot second plus x into y. Here what I did, so this x into y is the contribution for the current element, and this is what I explained to you on the whiteboard, that we are finding out some number which, so previous answers that we have already computed, that can be added to give this answer as this answer is maximum answer. So I will also create one variable answer which will initially be 0, and I will maximize this answer with maximum of answer and dp of x, and I will return answer. One more thing we have to do. What we have to do? We have to do one more thing. What what things we have to do? So we have to update the current answer. dp of x will be max of dp of x, and it could be it could be previous of sorry, it is not like the previous of itr. itr is the itr dot second. Okay, I think this could be. And one more thing, so here we are checking previous, so it might give you uh, runtime exception. The reason is ki you are this function, this upper bound will give you iterator. It is possible that it will give the first value, so it will give you the iterator, the begin iterator of this map. So when you do the previous, it will give you runtime error. So to uh, to prevent your code from the any runtime exception, try always try to handle the edge cases. So in this, we will first check if itr not equals to itr mp.begin. If it is not mp.begin, then only we will update this. Otherwise, there is no need, because we have to update with the previous. Okay. So there is possibility that even after contributing the last state with the current answer, it might be possible that its just previous state is higher than uh, the current state. That's why I have written this line, that I already explained it into the in on the whiteboard. So this is the overall idea of the problem. So let's try to run it whether it is correct or not. Something is missing. So let me give the semicolon. Mm, so it is giving incorrect value. What we missed here? Mm, what is something is missed? What we missed? Okay. So let's try to debug this for auto x in dp c out x dot first x dot second. So for one, it is giving us 4. That is incorrect. For one, it should give 2. Mhm. Oh, it is not MP, it's a DP. Let's try to see now. Okay, it is the incorrect answer. Let's try to submit it. Mm, oh, it is giving expected is 31. Okay, 2433. Okay, so let me first print this. So this is live debugging. What something we messed with the cout y dot y dot second. Let's try to run it for use this test case to debug. So here you can also see how I am debugging when I get some errors. So yeah. So for two, so let's I have to see how to start so that I can differentiate the actual
frequency map and the
So okay. So for 2, it is 4. It is correct. For 3, it should be 3. Fine. For 5, it should be 9. That is correct. Because for 5, yeah, it's 9. Correct. For 7, 7 can be paired up with 3. So 10 is correct. For 8, we are picking 8. 7 it cannot pick, but 5, it's 17. It's correct. For 9, 18, 18, 18. For 9, it's 18. For 3, it's 3. That is incorrect. Why it is incorrect? Mhm. Okay, yeah, yeah, we missed this. So we have to update it with the previous answer, not the upper bound answer. So you have to again find dp of find x, and I have to, if itr not equals to dp dot begin, I have I will update this answer with, yeah. So this is the overall. Now it should give the correct answer. Yeah. Let me. This is how we debug quickly when something is wrong. You have to see the intermediate values, why it is giving the incorrect answer. So let's try to submit it again. It should give correct answer. Okay. Why it is giving 0? Why it is giving as 0? Okay. What? Today I messed here. E. So for 1 it's a 3. Okay. Why my answer is 0? Hmm? Why it is 0? Answer is 0. This answer should be equals to max of dp of x, and dp of x is computing properly, and I am updating my answer with dp of x max of answer. Okay, so yeah, got it. It should update here, not there. So much I wrote it at wrong place. No, its logic is correct, but I missed it while writing. Yeah, it's got accepted. So this is the overall solution of this video. Please like it, subscribe to my channel, and if you have any query, please ping it into the comment box. I will try to answer in detail. And yeah, keep watching, and we'll see you uh, in next video. Thank you so much. Next video will be on arithmetic slices. Thank you so much for this video. Bye bye.